like I said, we're starting our last chapter, which is chapter 6 in your book, which is unit 8 in the CED. So remember your like AP stuff. So we just did differential equations, which was like our first example of like applications or how we use integrals. Okay. And then our last unit is just again more ways on how we can use and apply integrals. First off, let's think, what is an integral?
Area under a curve.
Yeah, and so if we were to look at two curves, we can actually find, so like let's say I had something like that. So what would my area under that curve look like?
The integral of f of x.
Yeah, and that would give me kind of my semicircle shape that I have right there.
Mm-hmm.
Yes. But let's say that I had some other graph and it went like that. Yes? Now I want to find the area between those two things instead. So the little like eye shape that's there. Okay. But what would the area under that curve be?
Integral of f of y.
Yeah, g of x, but
Yes.
what's it gonna look like?
Not the thing that you have shaded.
Okay, it's gonna be kind of the rectangular-ish shape, right? Except it's curved on the edges. That shape right there. Agreed? So how might I find the orange region?
F of x minus g of x.
Almost.
Integral.
Integral, yeah. So I'm still looking at the integral from a to b of f of x minus g of x, assuming that f is the blue graph and g is the green graph. Or in other words, we are doing top minus bottom. Yes? Now, I think we've looked at like one example of this in the past. We're going to look at more examples of this now. Okay? So the other way that we can see this is if I have something that looks like that. What is that graph with respect to? Is it an x graph?
Does respect to y.
Yeah, because notice that I have a sideways parabola, which means I'm going to have a y squared. Which means that we would actually take the integral with respect to y, so I'm going to have some function with y minus my other function with y. But when we're taking a function with y, okay, just like when we take it with x, I go to the x-axis. Here we are going left and right, so it is to the y-axis, which means that this is now right minus left. The other important thing to note is that these are y values. So like a and b would be on my y-axis versus here they're on my x-axis. Questions so far? So this says find the area bounded between the graph and the x-axis from 0 to 2. So I have an f of x. That's my first function. almost.
Or y equals 0.
Y equals 0. Yeah, the x-axis, which means I'm looking at that line right there, which is technically g of x equals 0. Yes, no, maybe? Now, the only thing we have to be careful about is where are we going from? 0 to 2. Okay. So I'm looking at this area and this area. Yes? And what did we say? How do we set up our integral? What minus what?
Top minus bottom.
Yeah. Is that a problem?
Yes.
Why?
Because the bottom is negative.
No. So which one's on top? Red graph or blue graph? The whole time?
No.
Ah, that's the problem though, right? Is that my interval has to be top minus bottom. Yes? But if those switch, then I have to switch them on my integral as well. Yes? Which means that I have to break apart my integral. Are we all okay with that? Okay. So I'm gonna go from 0 to 1. And on that one we have f of x minus 0. Right, because my f of x is on top. Yes.
What do you mean when you say top minus bottom?
Like this graph is above my other graph. The top graph
Like
minus
the
the bottom
area?
graph. No, like the curve. Like the red line is above the blue line. But after one, my blue line is above the red line.
That makes sense.
So then I have to add. Now I'm going from 1 to 2. But now my 0 is on top. Minus f of x dx. Yes, no, maybe. So if I simplify that, I go from 0 to 1 of f of x dx plus, what would this become? Just negative, so I'm going to pull that negative out. Why do I need a negative there?
Because the second one is under the graph, or under the x-axis.
Correct. And when I say area under the curve, or area between the curves, I don't care if that area is positive or negative. Yes? So when I take this second integral, I'm going to get a negative because it's under the x-axis, but I basically need to multiply that by another negative so that it ends up being positive. Does that make sense?
Yeah.
Okay. So then we can just plug and chug. Right? F of x is x squared minus 4x plus 3. So what is our antiderivative? What's the antiderivative of x squared?
1 over 3x cubed.
And the antiderivative of negative 4x?
Negative 2x squared.
Sorry, that should be a 3. I'll switch it. And then I have a plus 3x. Yes? And then the only difference about my second one is that we're going from 1 to 2 instead. So what do we plug in first on my first one? On the first one, 1. So I just get 1/3 minus 2 plus 3. What do I get when I plug in 0? Just 0. So I have minus 0 there. Minus, we're going to plug in what first? This one we plug in 2. So 2 cubed gives us 8 minus 4 plus 6. And then I'm subtracting what I get when I plug in 1. Yes, no, maybe. So if this was a free response question, what would my next step be?
Plugging it
Not
manually.
Nothing. We're gonna leave it where it is. Yes, because I plugged in all of my bounds. So from there, it's just algebra stuff, right? Or arithmetic stuff, really. That's what maybe?
Yes.
Now, multiple choice question. Are they gonna leave it like that? No. So we would need to do a little bit of computation there. Okay. But let's see. Notice that we have a bunch of thirds. So I have 1/3 minus 8/3 gives us almost negative 7/3. Yeah. Then I'm also subtracting a negative, so that becomes positive. So negative 7/3 plus 1/3 gives us 6/3, which is 2. Then I have negative 2 plus 3 gives us 1. Then this would be a negative 8 plus 6 gives us negative 2, but I am subtracting that, so that becomes positive. Yes? Negative 2 plus 3 gives us 1, but I am subtracting that, so that's a negative 1, but then we're subtracting that, so that becomes a positive 1. So then 2 plus 1 plus 2 plus 1 gives us
6.
6? We messed up somewhere.
It's the first two, it should be negative 2, because it was negative 6 things.
Ooh, there we go. So now what do we get?
2.
There we go. Thank you. Because notice, that kind of makes sense because these aren't triangles, but if I made them triangles, yes? This has a base of 1 and a height of 3, so my area would be 3/2, which is 1.5. This area is 1 by 1, which means it would have an area of 1/2, so 1.5 plus 1/2 gives us approximately 2. So, which is why I was saying nope, 6 is way too big there. Questions on that? Now, if this was calculator active, would I have had to do all that work?
Nope.
No, we could have plugged in this line right here, right into our calculator, and then it would just spit out 2. Alright, let's look at a more interesting one. So that one was with 0, just to kind of get us, like, think correctly about areas. However, most of the time, we're going to have 2 different functions. Okay? So it says find the area, should just be area, no G, bounded between the graphs. So I have an f of x and I have a g of x. Now, you are not going to be graded on graphs. Okay? Even on a free response question, you're not going to be graded on a graph. However, if I need to know what the top and the bottom are, what's it going to be really helpful to have? The graph. So I at least need to be able to sketch a rough sketch of what these graphs look like, because this one is a very valid non-calculator active. Okay. So let's think about, what does the graph of 2 minus x squared look like?
And upside down parabola. Let's translate it upwards to.
Okay. What does the graph of x look like?
Straight line.
All lines are straight.
It's a diagonal line.
Okay. Specifically, how diagonal?
Diagonal line.
One.
Slope of 1.
Slope of 1 and an intercept of
0,
0. So we would like something like that. Yes?
Yes.
Which means that this is the area that we are trying to find. So which of my functions is on top?
The first one.
The parabola, yeah. So I have 2 minus x squared. Then I'm going to subtract off my second, which is just dx. So I have something that looks like that. What are we missing?
Bounds.
Bounds. They don't give us bounds this time. So what do I use as my bounds? Oh, I need to find them. Okay, how do I find them?
You have to find where 2 minus x squared crosses the x.
not the x-axis.
Where they intersect.
Where they intersect. So notice that this area is cut off by this point and this point. Agreed? How do I find those points? Without plugging it into a vector.
Magic.
No. How do I find where two things intersect?
Oh.
Is it equal?
Yeah, I'm gonna set them equal to each other. Okay, and then how do I solve that? Also not magic. What type of function are we gonna have here?
Trinomial.
Yeah,
Trinomial quadratic.
specifically a quadratic. So I'm gonna move everything to one side, and then we would factor it. So what multiplies together give me -2, that adds together give me +1.
-1 and 1.
No.
-2 and -1.
No.
-1, +2.
There you go.
That's because of the
Because my middle term is positive, so 2 has to be positive. Which means that we get x equals a +1 and a -2. So then those become facts. Yes, no, me. Okay. And then it's just the same stuff we've been doing. What's the antiderivative of 2?
2x.
2x. What's the antiderivative of -x? Sorry.
-x cubed over 3.
And then the antiderivative of x. And we are going from -2. Which one do we plug in first? 1. So I get 2 minus 1/3 minus half. Yes? And then I'm subtracting, plugging in a -2. So I get -4 plus 8/3 minus 2. Wait, 4 times 1 passes. So it's negative. Again, for your response question, we stopped there. You technically didn't even have to like do the 8. You could have just put -2, -2, -2, and you'd be fine. Again, multiple choice questions, we are going to have to simplify a little bit. So I have 2 minus a -4, which gives us 6. Okay, but then I also have a minus a -2, so that becomes +2, so we get 8. Okay. Then I have a -1/3 minus an 8/3, which gives us -9/3, which is also a -3. This is why I say stop while you're ahead, and this is not a multiple choice question. You'll learn. Not always best at fractions. And then I just have a -1/2. So 8 minus 3 gives us 5. Minus a half gives us 4.5. And so that would be nice. What questions do we have there? Not too bad. So we can do one on our own. And go. time is pointing up. And yes, we are correct that those do not actually intersect, which is why I had to give you bounds. And we're looking at that, this part right here. If I did not give you bounds, then it does not exist, because it's an infinite area. So we're going from 0 to 1. I have f of x, because it's on top, minus a negative dx. So you should get 1/3 plus 2 plus 1/2, or also 17/6.
Or 2 plus 6.
Huh?
2 plus 6.
17/6. I don't know what that is in the decimal point. Decimal means so.
Why are you adding the x? Because it says y with negative x.
Because technically I'm subtracting,
Yeah.
right? Because technically this is f of x minus g of x. But if I have minus a negative, that becomes positive. I just did it in one step so I didn't have to like write it out again. No, but good question. Yep.
So why would you add this? Area under the curve for negative x.
Ah, okay. So this one is slightly different because the last time I ended up having to have a secondary integral. The reason I had to have that was not because the area was necessarily under the curve. I mean it was, but they like switch spots, right? Versus like these don't switch spots. So when we find area, this will still give us this entire area. The only time you would have to switch them like we did last time is, let's say you had something that looks like that, right? Now my top and bottom have flipped, so I would have to break that apart into 2 intervals. Because when I'm finding area between curves, it does not matter if it's positive area or negative area unless my top and bottoms flip. Then I have to separate those out. Yes, no, maybe. Do you see the difference between this one and then the first one that we did? Alright, let's look at, how much time do we have?
Yeah.
Oh, okay. Alright, what's different about this one?
F of y, so that's
Oh, I have y's. That's fun. So the reason that my graphs need to be in terms of y, okay, and then my bounds also need to be in terms of y. So remember the other way that we can write this, my g of y is actually my x. And the only reason I do that is because it makes it a little bit easier for us to solve so that I can graph it. Yes? No, maybe? Okay. If we distributed this y, what would the degree, the highest degree of y be?
y squared.
Yeah, we get a y squared, which means I'm going to get a parabola, but it's going to be a sideways parabola. Are we okay with that? Okay. It would also be a negative sideways parabola, so that means we open to the left. We open towards the negative, right? If it's positive, it opens towards the positive. Yes? And we also know if we set each of those equal to 0, what do we get as our intercepts? So like y equals 0. Yes? 2 minus y equals 0. So y equals 2. Yes? So somewhere up here. Yes, one maybe. So it looks something like that. Are we all okay with that? do we need now though?
Bounds.
Bounds. Okay. So I'm gonna go ahead and distribute that, right? So this would be 2y minus y squared equals a negative y. Because I'm setting them equal to each other. What should one of them end up being? Just by looking at my graph. 0. I should get a 0 somewhere. Because notice, if I add y, I get 3y minus y squared. So what can we factor out? A y. So we get y equals 0 and 3. So I'd have the interval from 0 to 3. The biggest difference, again, remember, instead of top minus bottom, we're doing what? Right minus left. So again, I'm going to have that 2y minus y squared. Again, minus a negative y. So this becomes 3y minus y squared. Hopefully we're all okay with taking the antiderivative from that point, yes? And then plugging in 0 and 3. And if we do that, we should end up with 9 halves. But like our antiderivative and plugging in works the same way. I just have y's instead of x's. So really the hard part is just finding those. Now again, if you were to graph this to find your intersects, you can't do that, okay? But just remember that when you're looking at these intersection points, these are going to be the y values, not the x values. It's like my x value would technically be negative something, right? But if I'm taking it in terms of y, my bounds also have to be in terms of y. Sorry, that should be a 3. Yes, Mo, baby?